All right, so what else? There was something I had to say. Oh, right, free things. Who wants free things? Awesome. I knew there was something I had to do. Yeah, that'll wake you up. Okay, cool. So we have two different sizes. We have a medium and an extra large. So if you are in the contending category for someone who wants a medium shirt, throw up your hands. Okay, now I have to. What's a good? Okay, here we go. So who has the cheesiest? I'm gonna do this. Who has the cheesiest like nerd developer joke out that wants a shirt? And whoever has the cheesiest, I'll give it to you. Maybe try 2 or 3 of you. Anyone? Anyone got a cheesy developer joke? Oh, come on. That's a letdown. I don't have one either. All right. Okay. What about?
I can tell you a joke about UDP, but you probably wouldn't get it.
Nice. I like it. We have an XL. Anyone? Someone just try and earn the shirt. Who wants to earn the shirt by doing something funny or yeah? Did I see a hand somewhere? No. No one wants the shirt? Anyone just want the shirt? Sweet. For those of you who didn't see that, that was basically... That was incredible. That was impressive. Okay, let me just grab my notes because I needed to... Oh, right. So at lunch... if any of you have any sort of special dietary requirements, there is a table that sort of facilitates for all of that, which is the end table in the room. So if you need that for whatever reason, you just don't go to the first or second, just go right to the end, and there's lots of goodies there for you. Okay, I think that was all. I think that was all the little sort of lecturing I had to give you. I think we should get Zach up on stage, and yeah, get going with your talk, my friend. Guys, Zach Holman from GitHub. Yeah.
Good morning. We're going to talk about moving fast and breaking nothing. You've all probably seen this quote before. Move fast and break things. Zuckerberg said this all the time. He would say it at least 2 times an hour. Most of the people at Facebook got upset about him. They're like, just say something else, just anything else, and they'll be fine. And he's like, nope, move fast and break things. This is the story for a long time. And then finally last year, this suddenly became move fast and fix things. I guess breaking is not in vogue anymore at Facebook. But if you look more and more from different engineers, this also turned into move fast with stable infra. I guess infra's hip to say, I guess, nowadays. Another developer said move fast and be bold. Obviously did not care about the infra as much as the other person. My favorite was Justin Timberlake's drop the it's cleaner from The Social Network. The greatest movie of all time. I think this is really interesting because I think moving quickly and safely is good philosophy. And this is kind of reflected in how Facebook was doing things. They originally were like, yeah, it's cool to break stuff. And now they're like, well, you can move fast, but maybe not break stuff as much anymore. I think that's a good philosophy to have in general. But that kind of means, well, what does that mean in practice? Like, I don't work for Facebook, but I can kind of guesstimate what that ended up happening. It means less broken product for their users. It means developers on their platform, their app won't get broken from things that Facebook does. So those are sort of guesses that we can make. But the more I thought about this, the more I thought it was kind of an interesting thing to think about. So this is what this talk is about. I'm Zach Holman. This is me with my favorite coworker's dog, Nala. I just love the eyes and stuff. Also, I got new batteries in this yesterday, so like, this just makes me think there's cupcakes right here or something. Anyway, I spent too long on this slide. 5 years ago, I started working at GitHub. I was number 9. We grew up to 250, 260 people now. A couple weeks back, GitHub came to me and they're like, we really appreciate your product direction and stuff. Would you like to be CEO? And I was like, yeah. And then I led us to an IPO and we all made lots and lots of money. I'm just kidding. They fired me a couple weeks ago. I was wondering what the reaction would be here. If like there would be like laughter. Like this side of the audience really found that funny. All of you guys are all like, oh, crap. It's all cool. What I'm trying to say here is this is going to be a super awkward talk for one of us in this room. And I'm done. So we're on good terms. I love GitHub. I love them forever. A lot of this talk is about GitHub, my experiences over the last 5 years, and a lot of, I talked to a lot of developers about their own perspectives on building things quickly and reliably. And I think this is just kind of a really interesting topic to talk about. So I built a talk around it. So the first thing to think about are kittens. You probably all have some sort of reaction to this GIF. Back when I first, yeah, like that. Back when I was first thinking about doing this talk, my friend IM'd me, and she said, "Do you know why kittens are so adorable?" And I was like, "I don't know, they're fuzzy or something?" And she's like, "It's so we don't fucking eat them." And it kind of blew my mind. I was like, well, I never thought to look at a kitten. I was like, I'm going to eat that or something because they're so adorable. I kind of went down this line of conversation in my head for a while, and I was like, well, kittens aren't wearing signs that say, "Don't eat me." Maybe as a byproduct of how cute they are, we don't eat these things. So that's where my brain is at most of the time in my life. And I kept thinking about this, and I started thinking about this in relation to product and building things. And it got me thinking about, can we build an environment where success is a byproduct? So getting away from this idea, instead of telling your employees, "Don't break shit," maybe you can build an environment to where they're less likely to break stuff. And I think that's a much better way to build a company. I think that's a much better way to build product. And I want to talk about 3 areas of that. So 3 areas we're talking about today are code. I think you have to get a little bit down deep into the actual code in order for that to sort of bubble up into a better product. So we'll talk about that. Process, just how you actually build stuff at your company, your organization, your open source project. And then finally, talking to people, communicating with your coworkers, collaborators, stuff like that. So let's jump into it, starting with code. If you go back to the whole idea of moving fast and breaking things, I think it's kind of nice to break that up and figure out what the hell we're talking about here. So moving fast, why do people want to move fast in the first place? I think people like fast because it ends up with better product. If you can get something out in the market as soon as possible, you can quickly see that, oh man, no one likes this, we should probably do something else, or people love this, let's just tweak this and go with this. The faster you can iterate, the better it is. I think most people kind of get that at this point. You can see what works. And the other thing I really appreciate is momentum. And this is kind of a thing that people don't necessarily associate with moving quickly. But there's a lot of momentum involved with a company that is pushing out a lot of great features and code and product launches and stuff. The first 6 months when I was at GitHub, I was working on basically enterprise sales support tickets, which is not the sexiest or glamorous or really a terribly interesting thing to work on. But I remember looking back, and that didn't really matter because everyone around me at the time was working on really amazing stuff. So it kind of gave me a bunch of momentum to work on what I'm doing and how can I improve and stuff like that. So I think this is like a really less talked about aspect of why moving quickly is really great for your organization. On the flip side, if you've ever been in a company that tends to move very slowly and don't end up shipping a lot of stuff, at least for me, it makes me want to drive spikes in my head or something. Like I just want to just ship anything. The more you can get more people shipping stuff, I think it's just better for your company. So that's moving fast. What about breaking things? Why do people even say this in the first part? They'll break things and then you can fix it later. They never really mention what this meant in the quote. And I think what's interesting to think about this is that most things you can break. 0.5% of users see something that's broken for 3 minutes. No one cares. Like, it doesn't matter. I think what's the really important part is to identify what can't you break. And this is probably going to be the minority of things that you end up doing, but these things become incredibly important to think about. So number one, billing. I can't just push out code willy-nilly and then accidentally charge you $1 million and be like, my bad, I was moving fast and breaking stuff. Turns out that's not cool for users and also probably illegal or something like that. So you can't necessarily go as quickly on billing code. Same thing with permissions code. That gets really dicey. You need to make sure that people can't have access to stuff that they can't or shouldn't have access to. Upgrading software, you should never do it because it always breaks stuff, but you should probably upgrade software and hardware at times. That's really hard to do very quickly and willy-nilly. And the last thing is kind of data migrations, anything where you're sort of tweaking the state of your data behind the scenes. A lot of the times, if you're pushing a lot of data around, it's really hard to just deploy that and just be like, all right, now I'm done. Sometimes they take months and months and months of work to do that. So I think the main question is, how do you move fast in this dicey code? Because I don't want to work at a company where 80% of the company is working on really fun, fast problems, and then 20% of them have to work on these sort of hard, dicey areas, and they have to work in a totally different manner. I don't think that's really cool to do. So one example that we had at GitHub, and I apologize, I'm still going to say we at GitHub. It makes me sad to think about. No, I don't know. My apologies in advance, but this was like a 2 or 3 year project where we realized that like our permissions system, trying to figure out, do you have access to this piece of code? Do you have access to this user, this permission? It was really slow, and it was brittle, caused bugs, all of that sort of thing. It was a good target for us to replace with something new, and we had a good idea of what we wanted to do to make it better. Now the difference is, this is hella scary. It's so scary to change permissions and stuff that I put hella for the first time in a talk. This is really scary. Like for GitHub, this is like the whole deal. Like if we push out a change to the permissions and lets people look into your private repositories, like that's the ball game. Like why do we even exist if that happens? So this can't happen. So if you look into the idea of only 0.1% of people were affected by this for like a couple minutes, that's really unacceptable in cases like this. This is something where 0 errors has to be absolutely mandatory, and you cannot break this type of code. So the question again is, how do we ship this really fast and really safely? Tests are really great. I don't think this is a big surprise anymore. I think people tend to realize that if you test your code, it ends up with a better code base. So if you have a good test suite, or if you don't have a good test suite, you should fix that as soon as possible. The real problem, I think, is that production can differ from what your tests expect. And if you ask pretty much everyone, no one says, my test suite is glorious. It's the best code I've ever written in my life. It's usually, yeah, my tests, we're going to fix that in the end of the year or something, and then the end of the year gets pushed back like a couple of decades and stuff. So test suites aren't necessarily the whole deal, necessarily. They can be inaccurate, they can be broken. But I think the really subtle part is production can even differ from what you expect. So when we were going to do the permissions change at GitHub, we had like nice long tables of if you're a user in this circumstance, you have access. If you're somebody else in this circumstance, you don't have access. Made total sense. It passed all of our tests. That was awesome. And then once we started getting stuff and looking at data in production, we realized what was in production was not actually what our model was in our heads. And this is like really strange. And it comes from different ways. Like sometimes the data in your database is impossible. Like you had some migration that half triggered in 2009. So there's like 40 users still that still have that bad data. And for some reason, that is the current state of the system. So even though you expect a good mental model and you think you have a good handle on it, if you change what production actually is, that's breaking the experience for the user, and that's the problem. So that's the rub, is to make sure that your code doesn't change production behavior. It's not green tests. It's not good performance necessarily. It's to make sure that your end user doesn't see a broken experience. So the team who ended up doing the permissions stuff ended up kind of coming down to this idea of parallel code paths, which I find to be super awesome. I love hearing the work that they did on this. So imagine a request coming into your app, and the request runs code. This is the normal state of the system. In this case, this is like the old code. We think this is broken, slow, inefficient, something like that. This always gets run as normal, but in parallel or right after each other, we'll also run the new code that we think is super fast, it's going to fix the world, whatever the case is. So we run both lines of the code base at once during the request, but then we only return the response from the first branch. So from the user's perspective, whatever code I put into production on the new side of things, the user only sees what happens on the old side. So we're basically doing two things at once and incurring the overhead of doing that, but that lets us get a lot of benefit out of that. Basically, you can run both and then you compare the results between the two of them. So we use Ruby at GitHub, so we wrote a Ruby library called Scientist. It used to be called DatScience, then we changed it to Scientist. This is the current version. It's Ruby, but I mean, anybody can basically write this in any language in like 70 lines or something. It's a very simple process. So forgive my opaque Ruby and stuff. But the way you use this is basically saying, okay, we're going to pass a block in, and we're going to say, for this particular request, use this slow authentication method or something, function. This is the one that always runs and returns your results. But we're also going to say e.try, try this fast new experimental code that we're still playing with. We think it's right, but we're not sure yet. And the cool part about this is that this can be run as a percentage as well. So if this is something that we think is good code, but we're really kind of nervous, like maybe this will slow down parts of the system we don't necessarily anticipate yet, we can run this to like 1% of users, get like half an hour of data, and then it doesn't actually impact the system as much as it possibly could. And then in Ruby, we wrap the whole thing in a block, and this does all the heavy lifting behind collecting the two results between the two paths and then comparing them. And this is the really fun part. We pipe everything into Graphite. Graphite is super important. Same with Etsy from the last talk. If you haven't used Graphite yet, you totally should. We run basically the entire business off of it. So in this case, the top blue bar is basically the number of attempts that we tried, like the number of requests basically that came in on this piece of code that we think we want to replace. The red line underneath is mismatches. So I'm saying that the old code is going to match up with the result of the new code. And in this case, at the beginning, we were basically wrong every single time. And then over the course of it, the developer said, okay, I think I found these edge cases. I'm going to fix some of these. And then this is the type of graph you want. It slowly goes down over time. And then towards the end, there's only 1 or 2 times where the new code doesn't match up with the results from the old code. So this is a nice way to empirically say what I'm changing in production is correct. I'm not changing production behavior. The other benefits of all this is that you can actually look at performance and other type of metrics like that. In this case, we're looking at the 75th and 99th percentile performance, so the really, really slow queries. A number of times when we've done these sort of refactorings, we feel, okay, the mean request time is going to plummet after we do this. This is good code. But then if you look at the far end of the extremes, sometimes you see like the 99th percentile is much slower. I think in this graph, the top 2 bars are the new pieces of code. So even though that may be faster on the base case, looking at these extremes ends up, it gives us information. Sometimes it's worth the trade-off. If I have 90% of my requests going to faster code, I can eat the performance degradation on the last 10%, and I'm totally fine with that. The point is that we can easily compare this and then graph this over time and then make these smart decisions. And that's really the powerful part. You can quickly iterate until you can prove safety. You can kind of get stuff out into production. I mean, GitHub deploys 200 or 300 times a day. So we want that type of pace to go as much as possible, but the user doesn't see anything breaking until we can actually say, yes, nothing will break here, we're confident in this, and then you can merge the stuff back in, and then you use the new code base. The other aspect behind the code line of things is I think building into your existing process becomes important, at least for me. Another way to ask this question is, what do you have today that you can already use? So to unravel this a little bit further, I think in an organization, especially when you're dealing with code or something, every layer of process you add is expensive. You look at the base case of, I want to get my code in production. All right, what does that mean in your organization? I make a commit, I push that commit up, maybe I open a pull request, I get code review, I go through testing. All of those are different layers of process for me to get my code into production. And I think every layer that you add is another step that cognitively, maybe a new employee has to learn the ropes of and then figure out before they can actually do real work. Instead, I think growing the process laterally is super important. So what does this actually mean? So take one example, tests are great. GitHub uses tests a whole bunch, and we run them really quickly. Our test suite runs in about 2 minutes or something like that. This is incredibly important for us. The real question was, can we just add more things to that line of that layer of process rather than adding a whole extra step? So what does that mean? For us, it meant like continuous integration as code maintenance. So if you're sending a pull request or you're sitting in code review, one of the first things you do is sit down and say, all right, this is JavaScript. Are there semicolons in here? Because like JavaScript people love semicolons or something like that. That's kind of stupid for an actual human who's paid decent salary to sit down and figure out, are there semicolons here or aren't there semicolons here? Why can't we just automate that away? So GitHub started moving towards that in a lot of really interesting ways that I thought. So as part of our CI builds, we'd actually have a failing test if you removed an HTML class without removing the actual corresponding class in the CSS. Like, this doesn't actually break anybody's user experience, but it improves code quality to do this. And like, you can't actually deploy the site unless you've gone back and removed that class. It's the same thing if you remove the CSS without removing the markup. If you add an image tag in our code base that's not on our CDN for security and privacy reasons, that's a failing test, and we don't let you go further. And then we also send all of our CSS through a linter, so more of the style perspective. The main point of this automates the grunt work out of code review, and it means there's less layers of process. So I can have, if I wanted Joe across the room to come in and review my code, he can come in and realize that he doesn't have to look at the style stuff, or that the image tags are right, or that CSS was properly formatted. He can just look at the content of the code instead of adding another step just to get code out. We took this idea to the extreme, and we ended up testing our blog posts. I wrote a post about this earlier this year. I found this kind of humorous. Going back really quick, at GitHub, if you write a feature, you are in charge of writing the blog post for it. It's kind of like a nice way to toot your own horn, saying, yeah, me and my team built this, check it out and stuff like that. So we have a repo where we all collaborate on blog posts and the marketing side of things. And we have tests for that markdown document. So if the image is off the CDN, that's a failing test, and you can't actually publish the blog post. If the image is too big, like for our mobile users, you can't just drop 10 megs on them, especially if you're in Australia. Your internet's really slow, sorry. And then often used phrase, we found, for whatever reason, we started our blog posts out by saying, today we announced blah, 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 which is really boring if you do that for every single post. So this is like a weird side effect of, rather than having, wasting time on someone's, you're having to go through like an editorial board or something, we could put this through a familiar process, CI, and do that. And I think one of the most important parts of streamlining the idea of getting your code out into production is to reduce the amount of barriers and steps to entry to do that. So that's some code-related stuff. I want to talk about process next. What's important is just a big question to ask in any company. And when we think about what feature launches need, it's a lot of different people, like developers, designers, down to lawyers, marketing, ops people. If you're in a big company, this involves lots and lots of people. If you're in a small company, this involves lots and lots of hats. So this involves just a lot of communication going back and forth. The more I've thought about this, about figuring out what's important in a product, in a feature, the more I've realized that text files are great. Flat files, as we have billions of tools and stuff out there, but the humble text file is one of my favorite things in the world. To take one example of this, Apple. They have something called the ANPP, the Apple New Product Process. It's basically a giant-ass checklist. Like, they have a bunch of tools surrounding the idea of, how do we format this, how do we collaborate on this, but at the end of the day, it's just a checklist of things that need to be done in order to make a new product for Apple. And this happens at various levels. This happens all the way up at the Tim Cook level and then down onto the very, very smallest of team level. Like, they all have sort of a checklist of saying, okay, how do I get from A to B when I'm trying to build product here? And this is kind of interesting with Apple. They do this from the very first step. If they have an idea of, Apple Watch 2 or something in a year from now, to get to that point, they'll start doing checklists and say, okay, this means we have to have manufacturing. This means we have to have developer, like stuff like that. And they just go as a very clear checklist. And I find that really fascinating. At GitHub, we had something kind of similar that we called ship lists. This is kind of, in comparison to Apple, this kind of happened as our last step. It's basically, again, just a checklist of things saying, in order for us to ship this particular feature, we need sign-off from these particular people on these particular aspects. Basically, it's just to-do lists for different teams. So if I'm going to launch a product, I can say, hey, CC GitHub/lawyers, which is our team of lawyers. Am I breaking the law by shipping this feature? And then they'd be like, no, or yeah, sometimes no. And then as soon as they have that checkoff, I can feel comfortable in shipping whatever I'm shipping. It's just a very easy way to collaborate without having to do crazy meetings or any other worthless things like that. Even NASA does this. Every sort of crappy sci-fi movie you've ever seen of a shuttle launch has checklists. No astronaut in any movie has ever just jumped in the shuttle and it's like, all right, let's go, and then just blast off. it's always like, serial main bus to B, check. Serial main bus to C, or like, it's very methodical. And the reason for that is that simple to-do lists make you think less. During a shuttle launch, the last thing you want to do is to argue, should this switch be like 20% or 30%? Once you actually get to the launching, it's just, well, I'm just going to read this, and then they're going to explode a rocket under me, and then I'm going off into space. It's much the same for product launches too. Every time, product launches are absolutely petrifying anyway, and it's stressful. And every time I've had a simple checklist of saying, all right, at 10 a.m., merge the code base. At 10:05, I do this. 10:10, I do this. It's just incredibly a wave of relief almost that I don't have to think about that because I put all of that thought into it ahead of time. Something else I've been thinking about a lot recently is the idea of ownership. In other words, it's just basically don't throw code over the wall. I have a problem with things like QA teams. I think that the ultimate responsibility of your code should be with you. You can have code review. You can have lots of people come in and help you out with your code, but I think not having people place the responsibility of their own code with themselves causes a lot of problems in a lot of development teams. And there's a lot of interesting ways to increase the responsibility of code. At GitHub, again, we basically try to notify you if you screw up. So if I deploy a piece of code to GitHub, Hubot, our friendly chat room robot, will say, oh man, we've been seeing a lot of elevated errors, exceptions and stuff on the site. Holman was the last one to deploy. Can you take a look at this? It's like a subtle nod and saying, you probably messed something up on the site. We want you to fix it. That's not to say GitHub doesn't have on-call engineers it's their ultimate responsibility to make sure that the site is working and everything. But it's so that you can get the attention of the people who are most likely to fix it the quickest as soon as you can. Because I think authors know their own code. The code I write, I know better than the code than you know my code. See, I'm already confused trying to figure out this in my head. But you know your own code a lot better, and I think you should fix your own bugs. So another good question to ask is, how can your process help you out with this? A really other interesting example is Chrome, specifically Chromium, the open source version of Google's Chrome. They have something that's called owner files. It's literally just all uppercase owner, and then they drop that into different subdirectories of the Chrome project. What this does basically dictates responsibility. It's a simple, again, flat file, text file that says, okay, these are the people who are in charge of this particular directory, module, whatever the case may be. This says that they are responsible for it, and you can look to them for help with this, or you can look to them to fix whatever problem that they might have for this. The other side effect of this is that it makes mentors very visible. So if I want to contribute back to Chrome, it'd be really hard to just be like, oh, I need help with this. Who wants to help? Like, do I email all@google.com or something? Like, is that like the process? But with owners files or something similar to that, I can just go straight into the piece of code that I want to change and say, okay, these 3 people are probably good people to ask for help on contributing to this particular piece of the project. That was kind of interesting. At GitHub, we had something that was basically on a much smaller level. We had per file ownership because we're a smaller organization than what Google is. So at the top of one of our controllers, we'd just basically have this method called that said area of responsibility, and then we'd pass in an actual GitHub team name. So in this case, in the branches controller, things that work on branches on GitHub.com, the Git team, the ones who work on the low-level Git stuff, would kind of own this particular file. And at that point, we could do a lot of really interesting things with this to sort of reflect on who owns a particular piece of file or a piece of code. So this is our exception tracking thing at GitHub. In this case, you can obviously see something broke on the right side, a lot of spikes and exceptions. And then based on where the line of code is throwing these errors, we can actually figure out, okay, these 3 teams are responsible for this particular piece of code. And at that point, you can talk to these particular teams and say, hey, did you see this? I want you to fix this because it's causing problems on the site. I think that's ultimately what you want, is that you want the issues that come from the code that you build to be assigned to the appropriate team. And that just gets things a lot faster. It gets your product improved a lot faster. Cool. Onward to talk, communication. I've given a lot of these talks over the years, and mostly what I would say, if you wanted to stereotype my talks, is more communication. I think having a more transparent company is a good thing. Getting more people to talk about stuff and have their opinions on saying, wow, this is really messed up, we need to fix this. That's better than saying, go off in the meeting room with like 2 managers and they're gonna come back and dictate what we wanna do. The problem with that is that with more communication, you have a lot more communication. And today, it's just getting worse and worse. Like issues and text messages and chat notifications, like there's a lot of inundation with communication. That is an awesome album name. Communication inundation? No? I crack myself up sometimes. So I think more communication is good, but the real rub is better communication is better. I mean, that's a good bumper sticker, but what does that actually mean? I think the number one thing that I've realized is that most things aren't emergencies. If you're at a company where every little bug or problem is an absolute drop everything and it's emergency, I think the company's doomed anyway. I think what you need to push back on is the idea that every little thing that may impact someone else slightly means that you have to drop what you're doing to work on something else. I think the best thing you can do for your organization is have developers who are really concentrated on what they're working on and not distracted by fires every couple of seconds. Because it's stressful too if you have to deal with your manager yelling, we need to fix this right now, stop what you're working on. So what that means to me is just be mindful of the time of your coworkers, people you work with, and any sort of request you make of them, realize that it's a real request, that it impacts what they may be working on or doing other stuff. So how can you measure the impact of your actions? I was at dinner with a former coworker, and she kind of mentioned this scenario, and it cracked me up. So imagine, you page a coworker for help. Maybe something's down, their service they wrote is just broken or something like that, and you mention them in chat or you text message them or whatever the case is. You're like, help, I need, something's broken. Maybe they get woken up because they're in America and you guys are cool in Australia and they're sleeping right now or something. And then immediately they open their phone and then their phone takes an immediate selfie of them and then that gets dropped into chat. If you saw this when you asked somebody, can you come up and fix something for me, would that change your opinion of asking them for help? And this is obviously an extreme example, but I think this happens throughout the day in lots of different contexts. And everyone's always working on something else. Some people allegedly have families outside of work, so if you ping them during then, it's a pain in the ass. It's a huge deal, but it feels like something, I feel like I should be able to pull you over because it's work, right? But the more you start realizing this, the better off your organization is, the healthier it is, I think. So add empathy to your process. I think empathy is kind of the most important part of product in some ways. And I think empathy stems from being exposed to real pain. So what does that mean? You've probably heard this before. Everyone should do some support. I know some companies do like a support rotation for new developers. When they come on, they have like 2 weeks or something with the support team. It's a good way to sort of feel, where are your users experiencing pain. Some other companies do this like, Fridays or something. You spend half your time on support. Or sometimes you do longer rotations where everyone does like 3 months rotation. The point is, I think this is a great thing to do. And as soon as you can get more people actually in front of the users, the better. Like when I was at GitHub, I probably read 85% of all the tweets to GitHub over the last 5 years. So I was pretty in tune with what people thought about our product. But that's still even different from talking to people on support. Because support are like real specific problems. I can't log in. I can't use your product. I can't do this. And getting people in front of that is just super beneficial for your ultimate product that you're trying to build. Because I think there's a difference between reading about it and actually helping it. If you actually have to sit down and be like, yeah, this is a quick fix. First of all, you log in. Second of all, you request this. Third of all, it's like, oh crap, these are a lot of steps. Like this is a pain in the butt. You wouldn't get that if you just got some sort of email digest from your support team saying, yeah, people are having problems logging in or something. So one huge area I've been thinking about a lot recently is the idea of institutional teaching. One of my favorite books I read last year was Creativity Inc. By one of the founders of Pixar. And there was a section that jumped out at me, and it read like this. We have a responsibility to be teachers. This should be a central part of our jobs, because it's just logic that someday we won't be here. This can be super ominous, meaning that you're going to get hit by a bus and die, and then no one will know how to do your job. which is the most important part, not that you're dead. But this also means things from like, you can get fired from your job. This section is like really loving that stuff. And then it's also things like you want people to transfer through an organization. As the organization grows, people are going to move to different teams. Some people are going to have vacations and stuff. So on a very day-to-day level, it becomes important that you want to spread knowledge as much as possible throughout the organization so more and more people know everyone else's jobs and can improve the entire state of the entire product. So, biggest oh duh moment in this entire talk, more productive. Your company is more productive if your workers are smart. So have smarter workers. So how do you teach without making it lame? I mean, that's how do you get people to be smarter? And I hate it when like you do a workshop at a company and you say, all right, now you're all going to learn this particular piece of software, because you've sat in this room for an hour with people that don't want to be there. Now you're all experts. And I think that's the worst way to teach in your company that you can possibly come up with. So something that I've been super in love with at GitHub is the idea of chat ops. Jesse Newland, who heads our ops team at GitHub, he did a talk specifically about this, so you can go and check that out if you're super interested. But I'll talk about it briefly here. It's basically learning by osmosis, specifically in kind of the DevOps or ops type of world. So if you look at kind of a normal workflow, if like your app crashes or the site is down or something like that, something that most people tend to do is like the employee gets paged and say, okay, something's down, and then they SSH into something, and then they fix it somehow. And then they'll close the issue saying, got it. And then even at that point, if you ask them, what the hell did you just do? And then they'd be like, oh yeah, I restarted a service. Here's the service. And that may be true. It's not necessarily reflective of reality, because every now and then, it would be helpful to know if they try to restart 2 other services ahead of time, and that didn't actually fix the problem. Like it's having a very clear, transparent steps to how they fix the problem, even if it's not the most efficient way. That helps me try and figure out, okay, how do we fix this for the next time? I think no visibility means no teaching. I can't learn from you if I can't actually see, at least on the broad strokes of what you're doing. And then no visibility means no improvement. Like if the app crashes every other day and you just still do the same steps to fix it, maybe we're missing out on a huge opportunity where we could just never have the app crash. That would be great. So there's a lot of ways you can sort of start doing this. GitHub uses Hubot a whole bunch, chat room robots and stuff. If you're on AWS, they have a great API. PagerDuty has a good API for sending out pages to other people. GitHub obviously has a great API too. So like an ideal world that I think is super helpful is the app crashes, the employee gets paged, and then they just do everything in a chat room. With GitHub, it's basically, Hubot initially started as kind of a front end, like a HTTP front end to shell scripts. So you would tell Hubot, restart service A or something, and that would run a bunch of shell scripts all tied together, and it would just automate a whole bunch of things for us. So having whoever's on call managing a chat room becomes very transparent, saying, okay, this service went down, and then she restarted these 5 services, and then it went back up. It's very obvious that these 5 steps are critical to doing this. And as they fix it, people can watch and then realize, okay, this is how we address this problem, or this is how we can get around this problem. This means that visibility means teaching. The rest of the organization gets a real good knowledge of what's going on. And it also means improvement. Like the number of times where I'd sat in a chat room and somebody's working on a project, so they're really heads down and they're doing like these 5 steps. It's very easy to sit back and be like, well, why don't we just make this one command? We'll tie these shell scripts up together, and then now we have something that used to take 10 minutes and we can do it in 1 minute or 0 minutes or something. Having that visibility where everyone can see what's going on in real time is just a huge impetus to start improving things on the organizational level. It's kind of another weird, funny story. When I was making this talk, something happened at GitHub. Our Wi-Fi went down on floor 2 in the office in San Francisco. I wasn't there at the time, but I followed this. I was in London at the time, I think, and I followed this because they basically what's the past of troubleshoot? Troubleshot? Troubleshot's way better. But they troubleshot this in an issue in real time. So Jesse was like, oh, the Wi-Fi is down. Here's like the switches and stuff. They all look good. Oh, there was one that's broken on the bottom. Here's like the trace route and stuff and the status of the particular router or something that we think is the problem. We have heat maps and stuff so we can visually see. I think the problem's right about there, I think. I don't know what red is, but I think that probably means the Wi-Fi is down. And then eventually he just kept going, and he went into the actual closet and took photos of the actual, this is the particular router that has a problem. And as they went through this, other people jumped in and were like, oh yeah, I had a problem with that last week, or that switch is wrong or something. And eventually they could get a replacement switch or whatever the case is. But the point is that this is very obviously in the clear that everyone can see what's going on. Like, I don't know anything about networking, but I learned a lot just from the steps he took to troubleshoot. And if it were something where it was just like a ticket and it said, can somebody fix the Wi-Fi, and they come back and say fixed, it's not a learning moment. And this is a good way to sort of just improve the efficiency of these sort of troubleshooting steps as you go on. So debug in the open. And I mean that from a code sort of standpoint, from an ops sort of standpoint, and even from like a process sort of standpoint, from like the Wi-Fi is down and stuff. I think that gives you so much gains in the long run that it's a good thing to do. The last thing I want to talk about today is feedback. The Blue Angels are great. This is kind of my rah-rah USA moment and stuff, but the Blue Angels are the US naval kind of performance flying stuff where they have like 6 or 7 planes, and they go to air shows and they fly within like 2 inches of each other, and they're amazing. Absolutely astounding. A year or so ago, I ran into this video. It looked like it was transferred straight from VHS, like in 1942 or something. But somebody put it on YouTube, and it was super interesting. I have no idea if I have sound. Do I have sound? Sound awesome. This is only like 45 seconds or something, but it's like the commander talking about how they deal with feedback.
After every flight, the team also goes through a critical debriefing process, which they consider as important as the actual flight itself. They hash out what worked, what didn't, and no punches are pulled.
We are wide open as we can possibly be to criticisms, and we want to become our own worst critics.
We debrief everything. I'll tell you how specific it gets. We even debrief the march to our airplanes and the march back. And you get picked on for every little thing. And most of us haven't marched in 10 years of being in the Navy, so they get very, very specific.
The debriefing process takes probably twice as long as the flight took itself. Rank doesn't come into play, experience levels. Those are good, but you have to set those aside when the criticism starts to come, because that's the only way you're going to learn the maneuver, and that's the only way you're going to get to where the maneuver looks good and it's safe.
So these people are absolutely insane. The idea that you can just give feedback and everyone's cool with it, like you basically have to be in the military to be able to deal with that, I think. And especially the whole idea of like a new member of the team can just, talk to their manager or their commander and just say like, oh yeah, you were really off base here. And for them to just be like, yeah, that's, right on. Like it takes a certain type of person to get to that level of professionalism, I guess. The reason why I want to play this is that I think it's a really interesting ideal, even if it's something that us mere mortals can almost get to that point. And I really like the idea of how they treat feedback, how important it is, how it's twice the length of the actual demonstration that they do. Because I think feedback is a two-way street. It's really important. The first that you have to do is how well do you receive feedback? And this is really hard, especially in code. For whatever reason, we'll be heads down for like a couple weeks, couple months, sometimes years on a piece of code, and then someone can jump in and say, this is so stupid. What the hell were you thinking? You're an idiot. If you've ever worked in open source whatsoever, you've experienced this over and over again. And it kind of sucks that you have to step back and realize, okay, they ostensibly talking about my code that has no reflection on me, but it's still really hard. And it's something you have to sit back and figure out, how can I improve this? But the other token of this is how do you give feedback better? And this is also really hard for a lot of us as well. It's very tempting to just stomp in on someone's code and say, this will never work. Don't even try this. It's a lot harder to step back and say, okay, how do I communicate my opinions without stomping on their feelings and stuff like that? My coworker called this a shit sandwich, where you basically give them something nice, and you give them the meat of something that's like they could improve upon, and then you give them something nice at the end. Something like that. It's super helpful, and it has a huge impact on how your product gets shaped over time. And I think the last thing is how well can feedback travel up and down the organization. Because if you have something where feedback only goes downhill, I don't think that's as beneficial. Like, you need to be able to tell people above you in positions of power and say, I think what we're doing here is just not right. And as soon as you don't have that sort of transfer of feedback honestly up and down the organization, man, it causes lots of problems. So spend a lot of time improving feedback across an org. It depends on what you actually need. Every organization is different. Some people literally probably just need better ways of figuring out how you can physically type feedback to people. Like, don't call people idiots. There's a lot of organizations that have a lot of people doing that. So I think it's worth stepping back and trying to figure out what does our organization need to make better feedback? How can we be more honest about it? How can we be more critical, but still kind of drive the product forward? So that's mostly what I have today. Moving fast with a degree of caution. It's less sexy to say, but I think it's super important. And I think you can have both. I think you really do need to be fast. I think you should be shipping as much product as much as possible. I think that's the best way to build good product. But I think you can also be safe with it too. It doesn't mean that you have to break stuff necessarily. And I think it takes effort to achieve both, but if you reach that good balance, man, it's awesome. Like, the ability to deploy like crazy and see your stuff changing in your user base and still not breaking stuff, it's totally worth it. So that's what I've got. Thanks. Do we do the questions thing? Yes, sir. Or wait, no, we got mics. What's going on here? That mic.
About building safe environments where success is a byproduct.
Mm-hmm.
Do you consider things like the hack language from Facebook as an example of them building an environment where success is a byproduct? Specifically with the type checking and strict types, and considering that their code base is so much PHP that that moving it towards that safer environment is possible.
I've become very jaded on code of all types. Like, I don't really care about languages or, different facets of frameworks that people may choose and stuff. So I don't view this as a question of tech. I think it's much more high level in terms of can you actually get work done without a lot of overhead and process and stuff. There are things that you have to dive into in every language, and I haven't used PHP in a while. That's my hidden secret. I don't know why I'm here. But I think it's just a stepping stool to get to the ultimate goal of how do I move quickly and safely and doing all of this sort of stuff. So I don't know. I'm just not super interested in, kind of. Programmers are really great at just bike shedding everything, and we had lots of arguments internally about like our C style or Ruby style, like whatever the case is. And I think one of the better things at GitHub is that people have those arguments and just they don't care about it as much, because it doesn't ultimately mean you create happier developers, I guess. So.
Zach, you spoke about promoting ownership of code and following problems back to the source. How do you balance that with the opposite problem, which is the somebody else's problem issue, where people either they'll color up to the lines and fix their bit and not worry about the connecting parts, or simply not fix problems?
I think it's tricky. Ultimately, what you want is an environment where people help each other. And I think one of the things I've noticed that it changes how I build code, because I don't want someone else to be responsible for my mess ups, all the way from like support down to other engineers and ops. And that's a hard environment to suddenly conjure up and implement. But I think maybe it's part of just hiring the right people who have respect for other people. And I think part of that is having the freedom of letting people fix things that are outside of their day-to-day job or something. Like what you ultimately want is that, if I'm supposed to deploy this feature, and that's like my main focus, if I'm on the way there and I see this other pile of code is a mess and I have a good idea of how to fix that and it's not my responsibility, you want people to feel comfortable and say, I'm going to let this slide for a little bit because I think this is important to fix this. And I think one of the problems with a lot of companies is that they don't give people the freedom and the flexibility to do that. They say like, oh, you have to do this and you can't, we'll fix that up in version 2.0, and you just never ever get there. And I think to get there, it has to kind of be a continuous process as you go.
Thanks.
At GitHub, who made the decision to run your culture like that? Was it from the top or was it from the bottom?
No, the culture thing was such a weird thing. It just sort of happened. I mean, the main reason why, some of the things we said in the past, like we're remote and we work, kind of on things as we wanted to work on. That mostly stemmed from like the founders. We didn't have an office for 2 or 3 years. They kind of worked like an open source project. And it wasn't a conscious decision. It just sort of happened based on this is how we wanted to work. And after like a couple of years and figuring out how it kind of worked, we started to write things internally about like this is what we think about so and so, and it kind of just evolved over time.
Yeah, I guess related to the same theme as well. If sort of a few people or a team own particular code, how do you then handle like knowledge transfer and people can leave or a whole team could leave, you lose all that knowledge. I mean, by sort of focusing it down to this with this ownership kind of concept.
I think there's like a lot of ways to help that. The number one is obviously documentation, like write a lot of documentation, code comments and stuff. That tends to get forgotten a lot by developers who feel like they're always in a hurry. The other aspect I think that was kind of a byproduct of at least how we worked is like we use pull requests for everything. So before your stuff gets into production, it's always in a pull request. And the number of times where I've had a problem with a particular piece of code where I was like, why would anybody write it like this? And then I go back to the code or the commit or something. At least having that context there, and even like 3 or 4 years later, having that context to go back to ends up being super helpful, at least for me in some cases, to figure out how to go on from there. So.
Yes. So at GitHub, who was basically responsible for the code documentation? I mean, a developer basically don't like to document things properly and would like to someone, basically a technical writer maybe, to do that. So.
There's no one answer for that, just because over the course of the last 6 or 7 years, that's changed dramatically. Early on, I don't think there was really much documentation because there weren't many people anyway. Eventually, with more and more people, it became, we had a big emphasis on documenting your own code, and like you couldn't get your code merged without having documentation and comments and stuff like that. And eventually, we got big enough to where we could have like a team, like a documentation team, both internal and external documentation. They helped out a whole bunch with that. And then just, I think, at least for us, as we grew, it became much easier to spend time on these sorts of things. I think the main problem is when you're 0 to 50 employees, and it's like things are going so quickly, and it's like I don't really want to spend time on documentation because the server's down. So I don't know. You get a little bit of a breather later on, hopefully, to start doing that in a better way. Looks like it's time. Thanks.